Hi everyone. So today's video is about this circuit which you may have seen in many other videos titled as a wireless energy transfer circuit. Basically in those videos they only show you how to make this circuit but they never explain how this circuit works. So today I will show you how to make this circuit, how it works and a thing or two extra if you keep watching till the end. So let's begin with making the circuit first. To make it you will need these components. Some enameled copper wire, a NPN transistor and a potentiometer. Here I am using a potentiometer instead of a fixed value resistor. To make the transmitter coil, we take the enameled copper wire and wind around 20 turns. Then we make a center loop and do another 20 turns. Then we remove it and secure it using zip ties so it doesn't unravel. Remove the insulation from the end so that we can solder it to the rest of the components. Next, we connect one end of the transmitter coil to the collector of the transistor. The other end we connect to one of the legs of the potentiometer. The other leg of the potentiometer goes to the base of our NPN transistor and the transmitter circuit is ready. To make the receiver coil, we make around 80 to 100 turns. Then we connect a LED to its ends. Here the polarity of the LED doesn't matter because the output of the receiver coil is AC. To power this circuit, we connect positive of our power source, which in my case is a 3.7 volt lithium ion battery, to the middle point of our transmitter coil, and the negative of the battery goes to the emitter of the transistor. Next, put the receiver coil on top of the transmitter coil. Then slowly decrease the value of the potentiometer and the receiver LED starts glowing. Adjust the potentiometer value slowly till we achieve maximum LED brightness. The brightness of the LED decreases as the distance between the two coils increases. As you can see, this circuit is pretty easy to make. Now let's understand how this circuit works. So we have two coils, and when our transmitter coil creates a changing magnetic field, it induces a voltage in our receiver coil and the LED glows. But now the question is, how does the circuit produce a changing magnetic field in the transmitter coil? The transmitter coil in combination with the transistor and the base resistor forms an oscillator circuit. Let's see the circuit diagram to understand its working. The transmitter coil is formed of two coils separated by the center loop. This part we will call the primary coil and this part we will call the feedback coil. The receiver coil is our secondary coil. Here initially the transistor is off, and because of the resistor here, a very small base current flows through the feedback coil and to the base of the transistor. So the transistor allows a small collector current to flow, which goes through the primary coil, which creates an increasing magnetic field. This increasing magnetic field induces a current in the feedback coil. The induced current is in this direction, and as you can see, it is in series with our supply. So it adds up and the base current increases, because of which the transistor allows a large collector current to flow, which increases the magnetic field in this coil even more, and now it induces a current in the secondary coil as well. And the LED in the secondary coil starts to glow. Once the collector current reaches its maximum, the magnetic field in the primary coil also becomes maximum. Since the magnetic field is not changing anymore, it stops inducing current in the feedback coil, due to which the base current decreases, so the collector current also decreases, and the magnetic field starts to collapse. This collapsing magnetic field induces a current in both of these coils, which is in reverse now. Here it opposes the base current, which now decreases so much that the transistor turns off completely and we are now back to the beginning. This cycle then repeats again and again, and we get a oscillating magnetic field in the transmitter coil. This setup acts as an air core transformer and uses the changing magnetic field in the primary to induce a voltage in the secondary. The voltage induced in the secondary coil is AC. We can confirm this by adding another LED in parallel to the first one, but in opposite polarity. And we can see both the LEDs are glowing. So the polarity of the LED doesn't matter. So this is the complete working of this circuit. This oscillator topology is very common. This is the circuit of a buck zapper racket. Here we have the transistor, the resistor and the transformer, which has all the coils. Here it is used to get a high voltage output by driving the transformer. The secondary in this transformer has a very high number of turns and a voltage multiplier stage, so we get several hundred volts at the output. Another example is this classical Joule thief circuit. It uses a low voltage power source like a 1.5 volt cell to light up a LED which requires around 3 volts. It does so by using the collapsing magnetic field to induce a voltage which is in series with our low supply voltage. The combined voltage gets high enough to light up the LED. This means that we should be able to run our original circuit with a 1.5 volt cell. We just have to adjust the potentiometer value, and as you can see, it works perfectly. The LED glows because our receiver coil has higher turns than the transmitter coil, so the induced voltage in the secondary is high enough to light up the LED. Also, the reason I'm using a potentiometer instead of a fixed value resistor is that the circuit oscillation is dependent on the base current. Too less or too much base current and the circuit won't oscillate. With the potentiometer, we can properly adjust the base current. If I decrease the resistance too much, the LED turns off as the oscillation in the transmitter dies off. And we also risk damaging our potentiometer and the transistor because of too much base current. You can also change the form of the coils. Here I made the transmitter coil like this. The outer coil is the primary coil and the center coil is the feedback coil. This also works very well. I made this one using a BC548 transistor, and this also works just fine. You also don't need only a NPN transistor to make this. A PNP transistor will also work. In this circuit, I am using the BC557 PNP transistor. The connection of the coil to its pins remains the same, but we have to reverse the polarity of the power supply. This time we connect positive of our power source to the emitter of the transistor, and the negative goes to the center loop of the coil. And once again, this circuit also works. So you can also make this with a PNP transistor. So this was all for today. Maybe in future video I will show you how to make a simple and harmless stager with this circuit. I really hope you learned something new from this video. And if you did, then please like this video and subscribe the channel for future videos. I know my voiceover and video quality are not the best, but I will try to improve them, and I assure you the future videos are going to be much better than this. So stay tuned for upcoming videos, and once again, thanks for watching.